Dear students, I welcome you for the today's lecture related to the dynamic behavior and stability of closed loop control system. For that, we must understand what is the block diagram algebra. Now, basically, the first and most important consideration from the perspective of industrial aspect is that to understand the block diagram and to understand the control loop. What are the different control loops? How your equipments they are connected with the control loop. This is in general is the basic understanding of a process engineer. I'm talking about only the process engineer and not the controller detailing person. For a process person, the knowledge related to the basic knowledge related to the block diagram, its representation and how the control loops they are present. And for a little bit higher or senior persons, how its stability is to be maintained. For that particular understanding, the controller gain, the value of the controller gain, the proportional controller, proportional integral controller, proportional derivative controller, and proportional derivative and integral controller, its constant values, what should be provided. That is the basic overall requirement of a process engineer. Very few people go, those persons who are in the designing of this controller, they only study the stability with respect to Raoult's array, Ziegler-Nicholas controller settings. All these are your advanced. But for a preliminary process engineer, one must understand what is a block diagram, how the control loops are, what is a control valve, how it works, and how the signals they are transmitted from one place to the another. That is the basic understanding of a process engineer. So in this respect, we are basically we will see some examples related to our chemical equipments. That is a simple liquid level control system. Now I want to maintain the level of this tank. This is a liquid level control system. That means I'm going to maintain a certain fixed level into this tank. For that purpose, I will require a level measuring instrument first. So I have to attach a certain level measuring instrument to this vessel, and then a level transmitter that is to be provided. First is the measurement, and then that level is to be transmitted electronically. This is to be transmitted. Where this transmitted signal goes, that goes to a level controller. So this is the action of a controller. This is the controller situated. Now this controller takes a certain action and sends the signal to the control valve. This control valve adjusts its position, valve position, stem position, so that the inlet flow rate and or the inlet flow rate which is going to the tank, that will be adjusted. It will be either increased or decreased or will be maintained constant depending on the input, measured input level. This controller that is to be provided with a certain set point also. Now in this case, there is the another flow rate that is also entering into the tank. We'll see the purpose of these two different flow rates. Only the one flow rate is getting controlled because this is provided Q2, that is provided with a control valve. Q1 is not provided with a control valve. Then coming to the next example, That is, here we want to maintain a certain temperature into this tank. For that purpose, a measuring temperature measuring element, a thermocouple, that is provided, which measures the actual value of the fluid inside this tank, and it sends the signal to the temperature transmitter. Previously it was a level transmitter, now it is a temperature transmitter TT. This temperature transmitter sends a signal to the temperature controller TC. This temperature controller takes a certain action and sends the signal to the heater. This heater will adjust its resistance voltages, so that if the temperature is less, so that it is going to increase the supply, and alternatively the more heat will be transferred to the tank. Here again there is another flow which is having a temperature. Here only one flow rate that is there. In previous example there are two variables are there. This is measured liquid temperature with a thermocouple. Transmit the signal to the controller. Transmit the measured temperature signal to the controller. This controller performs certain calculations and it sends a signal to the heater. Then in this process, control system components, sensor which sense the temperature, which sense the pressure, which sense the flow rate, which sense the level. There are different types of sensors. Then there is a transmitter. This transmitter, whatever the measured signals are there, they are transmitted to a controller. The measured values from this sensor that is transmitted to the controller. TC is here controller, temperature controller, lever controller, pressure controller. Temperature transmitter will send the signal to the temperature controller. Pressure transmitter will send the signal to the pressure controller. Then it is sending the final signal or the final control element, that is your control valve. Now coming to the third figure, similar figure. Here in this case there is a temperature flow rate which is provided with a inlet temperature Ti and the flow rate is the G. Here also we are measuring the temperature, the same figure. Instead of electrical heating, it is a pneumatic control valve that is provided, and the heating is done with the help of a steam. Steam, that is the input. We are trying to maintain the temperature inside this reactor. Now what are the different factors that has to be considered, or terminologies? And these terminologies are very, very important for a process engineer. So this temperature inside the tank that is to be maintained, first it is to be measured, and then it sends to the temperature transmitter that sends to the signal to the temperature controller or the recorder, and then it sends to the signal to the control valve, so that the control valve adjusts its position, and accordingly the input of the steam into the coils that will be manipulated. Now there are different terminologies. R is the set point or the desired value measured by the temperature TR. TR is the measured value, that is TR is the set point what is given to this controller. For this controller, TR is the measured set point that is given. Tr is the temperature. R is nothing but your set point. This is the R that is provided to the controller. Then there is a Tc, that is the controlled variable that is there. Controlled variable is the desired product that should be at this temperature Tc. C is the controlled variable and having the temperature Tr. That means when my system will be achieving the desired target or desired value, when the set point that is equal to the controlled variable, that means Tr should be equal to Tc, temperature of the controlled variable, is equal to the desired value or the set point. This is my target. Once this target that is achieved, then controller will remain standstill, or else it has to take a certain action depending on the error that is generated. So M is the manipulated variable. M is the manipulated variable. That is this manipulated variable, the output signal of a controller, the output signal from this controller, it goes to the final control element, that is to a control valve, and it adjusts its position depending on the signal from the controller. So this is what the M, that is the manipulated variable, is nothing but the position of the final control element, the position of a control valve. कंट्रोल वॉल्व का ओपनिंग कितना रखने का है, कम करने का है या ज्यादा करने का है, that is to be decided by the controller. That means how much amount of the steam that should enter inside these coils, that is finally adjusted with this manipulated variable, which is provided the signal with this pneumatic control valve. This adjust, that is called a manipulated variable. Then B, that is the measured value. Whatever the temperature that is measured here by the thermocouple, it is measured by temperature measuring element. This is your temperature measuring element. Then there is a temperature transmitter, TT, that is your temperature transmitter. This temperature transmitter sends the value B. It sends the value B, that is the measured value of a temperature indicated by a sensor. B is the measured value. This measured value that is going into the temperature controller. This is a temperature transmitter. It sends a signal to the temperature controller. This controller that is already provided with a certain set point R. So what is the, if the measured value and the set point they are same, then there is no action. But if the measured value and the generated and the provided set point, there is a difference, then the error that is generated, this error that is E, which is equal to R minus B. This is called R minus B, that is the error generating. So this is the negative feedback control system. Set point minus the measured value. R is your set point and B is the measured value. If that is there, it's a negative feedback system. Minus B is your negative feedback. if this is the minus sign with the measured value, that is your negative feedback that is provided. So this is termed as the negative feedback system. That means the measured value transmitted by a temperature transmitter, that is in terms of a B, that is going to a controller, where controller compares that with a provided set value R and generates a certain signal, or the generates an error E. This is R minus B, which is equal to the E. R is the set point, B is the measured value. If there is a negative measured value, then the error that will be generated. This generated error then goes to the controller, where controller takes the action. Then there is a UI, that is also, U is also there. That is the disturbance variable. And it is the Ti, that is the temperature, the inlet temperature of a fluid. Now, if the inlet temperature of a fluid that is remaining constant, so there is no disturbance that is there. But however, the process, there is certain disturbance in the previous process, and the reactant which is coming, which was at a temperature Ti, got disturbed to T2. So that is your load variable. This is your temperature of the inlet stream itself as a load variable. Then that is one load variable. Then second load variable, that is the temperature of the input steam, that can also vary. The pressure of the steam, that can also vary. So that is, there are two load variables are there. We are assuming that the pressure remains constant. Some disturbances, instead of superheated steam, it comes with a saturated steam, depending on all the factors that can be there. But generally, this steam pressure that remains constant, and this process variable that may change, and this is considered to be as the load variable or the disturbance variable. It is also referred as the load variable. So these 6 terminologies, they are very important. That is, R is your set point or the desired value. This is, say I want to try to measure the maintain the temperature at a 50 degrees Celsius. That is my set point that is provided. But the actual measured temperature is less than that, say 45 degrees Celsius. So it's a less than that. So error that is generated, that goes to the controller, and controller takes an action so that more amount of the steam that should enter into this coils. As a result, the temperature slightly increases, and again it reaches to the 47 degrees Celsius. Still there is an error. So again a slight increase in the control valve will be slightly open, so that more amount of the steam will enter into the process, and as a result the temperature may increase. Now say if the temperature has increased to the 52 degrees Celsius instead of 50 degree, which is the desired, then again there is an error that will be generated, and this process continues till I will attain the 50 degrees Celsius as my controlled variable temperature and the desired set point temperature. TR equals to the TC जब तक नहीं आता है तब तक कंट्रोलर अपनी एक्शन करते रहेगा. So this R is your set point, TC is the control variable, M is the manipulated variable. Manipulated variable is the position of a control valve. U is the load variable or a disturbance variable. E is the error generated, and B is the measured value. Now, in addition to that, we will see the different process upsets. In this, the load variable is your temperature Ti, or sometimes it can be the steam pressure also. So temperature, flow rate, reaction rate, pressure, etc., that are going to change the product quality. These are your process upsets. The failure of the equipment or the process, that may be because of these process upsets. The control variable are the variables that we want to maintain at a constant or specified value. That should be desired temperature, and the control variable should be same, Tr, which is equal to the Tc. Then manipulated variables are the variables that are intentionally changed to maintain our control variable at a constant value. That is the position of the final control element, that is the valves, by opening or closing the valve. Then measured variables are the variables that are measured with certain meter, and the control variables or variables that we use to calculate the controller variables. Then this is what a controller behaves. A certain measurement, it provides the input to the controller. For a controller, the set point that is also there, commonly from the operator generally, I am going to provide the desired value. Say in the previous case, 50 degrees Celsius for the desired temperature set point, that is what? Meter, it gives the temperature measurement, and this controller gives the output, which is sent to the final control element. This is the electrical or pneumatic signals indicated by these dash lines. Then controller operation. If the input is different than the set point, the output signal is going to change. If the input signal is the same as the set point, the output signal remains the same. That is what, if there is no error, no manipulated variable adjustment will be there. Manipulated variable will remain as it is. Now, coming to the block diagram of this process which we have talked. Set point, this is your comparator. For the comparator, R that is provided, and the feedback system of B, this is nothing but the signal obtained from the measuring element. Then it generates a certain error E. That error E goes to a controller. Controller takes a certain action, and it gives the signal in terms of a pressure P to the control valve. Control valve adjusts its position so that the flow rate or the steam which is going into the process, that will be manipulated, that is a manipulated variable, and it goes to the process comparator, where the U, that is the load variable. This load variable in this case, that is not taken into account. The temperature Ti, that can be your load variable, and all this is going to a process. So process की जो measured value है, that is measured by measuring element, it generates a value B, which is a negative feedback to the system. It goes to a comparator. Comparator generates a error. That error goes to a controller. Controller takes a certain action. It develops a pressure which is going to a control valve. This control valve provides the manipulated variable that goes to a process. Now this is what we have represented it in a block diagram. Now reducing this block diagram in terms of a transfer function. So controller is having a transfer function of GC. Control valve that is having a transfer function of GV. The process that is having a transfer function of GP. And the measuring element that is having a transfer function of the H. We have already seen the derivation related to the process. That is, for example, we want to maintain the temperature of a reactor. We want to maintain the temperature level of a vessel. That is the actually process. Measuring element is your thermometer, thermocouples, level measurements, pressure measurements. Then your controller and control valve, they will be always there. So without that controller and control valve, no action will be taken. So the transfer function, this process, that is either first order process or second order process, that can be there. If it's a simple reactor, then it's a first order process which is having the transfer function Gp, which is equal to 1 upon 1 plus tau s. Similarly, the measuring element, which is having the transfer function of 1 upon 1 plus tau s. So this is the block diagram representation. This is what a comparator is. Then there can be the similar examples, a typical feedback control loop for a heat exchanger. The inlet temperature that is there, the outlet temperature, we want to measure and control that outlet temperature from the heat exchanger. So that temperature measurement is there, temperature transmitter is there, then temperature controller, then manipulated variable or manipulated value that is going to a control valve, which is a steam, which is going to a control, which is going to the heat exchanger. So this is a typical process. Whatever, you can take the level transmitter, you can take the temperature transmitter, you can take the pressure transmitter, whatever it may be the situation. So always there is a controller, control valve, and the heater. There are number of heaters that can be increased, a sensor that will be there. So this is a standard block diagram. Now the sensors produces a physical response related to the process variable. That is, your thermocouple's temperature is measured in terms of the millivolt signal. Then there is a transmitter. We are having the convert the signal, sensor signal, to the signal appropriate for the controller. Generally, the temperature transmitter, that is a millivolt signal, is there. So either in terms of current or voltages, this sensor provides the signal. Thermocouple provides the signal in terms of a millivolt. So generally it's a 4 to 20 milliamps and 1 to 5 volts. That is considered to be the standard 4 to 20 milliampere current, and 1 to 5 volts is your voltage, which is considered to be standard in our process control. And it is all operated with a pneumatic pressure of 3 to 15 psig. 14.7 psig is nothing but 1 atmospheric pressure. So this pneumatic pressure is 3 to 15 psig, not a very high pressure. It's a simple just 1 atmospheric pressure. So these are the three standard ranges. That is analog signal, that is 4 to 20 milliamperes with a voltage of 1 to 5 volts, and the pneumatic signals is having a pressure of 3 to 15 psi. So these sensors, they are depending on the type of the sensor, they produce the voltage or they produce the current. Then that is going to a transmitter. Then this transmitter, there are transmission lines, pneumatic transmitters or electrical transmitters. This pneumatic transmitters, in this case, pneumatic is your air operated or fluid operated, and the electrical transmitters are there. Then there is a transducers. Transducers basically convert the signal from one form to the another. That is the basic purpose of a transducer, converting the signal from one form to the another form. Mechanical form is converted into the electrical form. The pressure, in case of a pressure transmitter, that pressure transducer that will be attached there, so that for a generally what is there for pressure measurement, it's a diaphragm that is provided, and whatever the pressure exerted on the diaphragm, that is converted into the electrical signal. So the pneumatic is converted to the electrical signal. That is called the P to I converter. And there are I to P converters also. That is your current. I is nothing but your current and P is your pressure or pneumatic signal. So these are the I to P converters, that is current signal to the pneumatic signal, or there can be the P to I converters where it is the pneumatic signal to the current signal. I to P converter and P to I converters. Where that is to be provided, again that depends on the situation. Which transmitter I require. From a sensor to electrical, I will require the P to I converter. And from controller to the control valve, I will require I to P converter. Controller, that is completely an electronic system. It only understands the electric signals. That is either 4 to 20 milliamperes or 1 to 5 volts. That is what only the controller talks of. Controller में कुछ changes नहीं है. But your measuring sensor, they can be either the electrical measuring sensors or mechanical or strain gauges, whatever it can be. So you have to convert that sensor signal into the electrical part. Then and only then that can be transmitted. Voltage or current, that can be only transmitted by converting this. If there is a load cells to measure the weight, you require the load cells. Load cells, they are the strain gauges. Strain gauges, that is converted into the electrical signals. There you require a transducer. So these strain transducers, they are required and they convert this mechanical energy into the electrical energy. Temperature transducers, temperature transmitters. Temperature, it is either always talked, generally it is in the resistances or the millivolts. So these are your standard things which is required. Then these transducers, that is the output signal from the in the one form of voltage is usually fed to the transducer, which converts it to the pneumatic signal in the form of a pressure signal. Now when this I to P converter, that is from the controller, it sends the signal to the pressure valve, control valve. Now these control valves, they are operated with a pneumatic control. They are not operated directly in terms of electrical signals. Their position, वॉल की पोजीशन जो कुछ है, वो वॉल की पोजीशन न्यूमेटिकली ऑपरेट होती है. We will see how the valve works. There you will understand in a better way. So the I pressure will be supplied to a control valve, and this control valve adjusts its position according to the supplied pressure. Controller talks in terms of electronics. Control valve talks in terms of a pressure. So there is a requirement of a transducer which converts the electrical signal into the pressure signal. And that is the basic purpose of a transducer. Then this sensor measuring criteria, measurement ranges must cover the anticipating range of the measured value, performance accuracy, then repeatability, speed of response, etc. that is required for a sensor, then reliability of a sensor, that is acceptable change of failure, then material of construction of a sensor, then prior experience, how that sensor works, then safety failures as acceptable impact on the process safety. So this is a temperature probe and this is your temperature transmitter. It sends this signal into the control room. So there is a temperature, a thermocouple, a resistance or the temperature detector, RTD resistance is there. Then flow, orifice meter or venturi meter is there. Pressure, the strain gauges or piezoelectric transducers are there. Then for level, pressure taps or float activated chain gauges are there. Composition you require to measure with the help of a gas chromatography or mass spectrometry. So all these different measurements they require into the industries. Then generally your 4 to 20 milliampere, that is the current range. So if the sensor gain, I have to measure the temperature from 50 degrees Celsius to 150 degrees Celsius. So I will keep the minimum 50 degrees Celsius as the 4 milliamperes and 150 degrees Celsius as the 20 milliamperes. And accordingly, I will get or keep the ranges by using certain formula so that the sensors will be calibrated accordingly. So similarly, the level I want to measure from 0 to 100%, I will use 4 to 20 milliamperes for level. For minimum level 4 milliamperes, for maximum level 20 milliamperes, and in between that if 5 milliamperes is their current, it has to be calibrated, all these things. Then there are types of the controller, that is the feedback controller, feed forward controller, and the cascade controller. Feedback controller, when the control variable change or is different than the set point, the controller adjusts the manipulated variable to bring the control variable back to the set point value. That means when a control variable changes, I am going to measure the control variable. I am going to measure the output. I am going to measure the output. जो कुछ रिएक्शन के बाद में, जो प्रोसेस के बाद में जो निकल रहा है, उसके मेजरमेंट्स कर रहा हूं मैं, and then that signal is sent back. That is the feedback control system. When the control variable, that is the measured variable, is different than the set point, the controller adjusts the manipulated variable. The control variable must change for a controller action to be taken. Then there is a feed forward. The measured variables are used to change the manipulated variables before change in the control variable. Control variable तक जाने ही नहीं देंगे. मैं क्या मेजर करूंगा? जो इनपुट्स है, जो कुछ इनपुट्स है वो मेजर करूंगा, and accordingly I will measure the inlet temperature, I will measure the steam pressure, that will be compared, and it will be that much amount of the steam that will go into the vessel. So that is the feed forward and feed backward controller. Then there is a third, cascade controller. This is a series of controllers. The first controller output is a set point for the second controller. This is interesting. The first controller output is set to the second controller input, set point of the second controller. So there is more than one controller I am using. That is called a cascade controller. Means the second controller is provided with this input from the first controller. So these are the different types of controller that we will understand step by step. Now there is this is a block diagram reduction that we are going to discuss. Now this is your block diagram reduction. Till now we have used the R, which is having the set point for the inlet, then C, which is the output, then the B, measured value, this is the R, this is the B, error generated measured value, this is for the C, and this is for the U load variable. Then this is set point that is provided, it goes to the comparator, then this generates R minus B, which is going to give you the error E, that goes to a GC, that is a controller. Then this controller, it sends the signal in terms of a pressure to a control valve, This control valve adjusts its position M and it sends a signal to the process, and then that is measured to give you the control variable. So this is the general representation yp, that is set point, y is your measured variable, then the ym is your manipulated variable, which way that depends on book to book, the different signals are there. Ultimately the process block diagram, that is also the same. Now I am going to discuss the block diagram reduction. So this is a process, simple process, that is u and you get the x3, whatever the nomenclatures you want to give, you can change it. Now G1, u is input for G1, that is your process, and output from the process is x1. G2 is the transfer function for the second unit, and the output from that is the x2. G3 is the transfer function of the third unit, and the output from that is the x3. So x1, which is equal to G1 into u, x1 which is G1 into u, x2 which is equal to the G2 into the x1, x3 which is equal to G3 into the x2. So this is the block diagram or the each individual unit. How we write? The output upon the input, which is the transfer function. Output Laplace transform of the output deviation variable upon Laplace transform of the input deviation variable. That is what? A transfer function G1, which is nothing but the Laplace transform of the output deviation variable. In this case, x1 is your output deviation variable upon the u, that is input deviation variable. From this formula, we are writing this x1, which is equal to G1 into the u. Similarly, we can write for this x2 and x3. Every time we are using the transfer function, which is nothing but the Laplace transform of the output deviation variable upon input deviation variable. So this is by process successive subtraction. You can get the x3 substitution. You can get the x3, which is equal to G3, G2, G1 into the u. So x3, that comes as the G1 into the u.